So how do we actually use X-ray diffraction to determine the composition of our films? Well, there are a couple of steps to the process. First, as with all the other steps in the process, everything has to be super clean. So we triple rinse it, which means first we rinse it in trichloroethylene and put it in the sonic shaker and shake it for 5 minutes. Then we do the same thing in acetone and then in methanol. Once we're sure it's clean, this is a front view of the vacuum plate on the X-ray diffraction machine. And each of these little holes has just a little pool of vacuum. So there's air sucked in through each of those little holes. And you can see the sample is right here. And we try and position the sample in the middle of the plate and also over at least 2 of the holes so that it's held on there nice and strong and it doesn't shift around during this very sensitive measurement. So you can see here is the machine itself. This is the sample plate that we were just looking at. So this is an aluminum plate. There's our sample right there. And the detector moves around sort of in a circle here. And the sample itself also changes its orientation, whether it's here or whether it shifts 90 degrees for the X, Y, and Z directions. And then here's the X-ray source right here. So first it will scan it, so it figures out where on this big aluminum plate the sample is actually located. Then, and this is a wider view, you can see the sample is right here in the middle. Here is that arm that I was showing you before. Here's the other arm right here. This is sort of the guts of the machine are underneath this panel, and it has a cooling system to make sure it doesn't overheat. And then this is the safety warning light to tell you that X-rays are present, and this whole thing is sealed and closed off from any sort of X-rays getting out of the machine. The doors are very sensitive and they're sort of an alarm system, so if you open the doors improperly, it'll shut off the machine, and you know, that's bad. It's a very expensive machine, so you have to be very careful about that. And then there are panels over here that control, you know, pressing the open button so you can open the door and get to the sample. And then it's also connected to a computer that's over on this side of the lab that collects the data from the sample. So then we irradiate the sample with X-rays. And it measures the peaks according to Bragg's law that you saw when you investigated X-ray diffraction, and each of these peaks corresponds to a particular location in the lattice, and this is an example of LCPMO, which is lanthanum, calcium, lead, manganese, and oxygen in the sample, and these are the 4 targets that the sample was deposited with, and the last thing is the substrate that it was deposited on, which is silicone. And some of these say AL, which means the aluminum plate that the sample is resting on, and then some of them will be for each of the peaks that relate to the substrate materials, or the target materials that were used to create the thin film. So this is really verifying the lattice construction of the thin film to make sure that it produced what we thought it produced.